Hi, I'm Autumn Kim, and I'm a senior at Greenwich High School. And this year, I worked on a project entitled The Design of an Iron Oxide, Bentonite, and Graphite-Coated Polyurethane Sponge for Economical and Eco-Friendly Oil Spill Recovery. Each year, around 1.3 million gallons of crude oil is spilled into the ocean. Additional methods of oil spill cleanup, such as booms and skimmers, are often very expensive and harmful to the environment and only collect the visible surface level oil left after an oil spill and leaves soluble oil to continually harm ocean life. Using bentonite, an inexpensive clay, graphite, whose hydrophobic interactions attract oil, and iron oxide, which is magnetic and can help with oil maneuverability, I embedded them all into a polyurethane sponge that can remediate and recover both high levels of insoluble excess oil contamination in water, as well as soluble undetectable contaminants. So one of the first questions I had was how I could model oil contamination in water. And it turns out because of the many hydrocarbons in oil is able to fluoresce. And using gasoline as my model contaminant and benzene as a quantitative marker, I was able to use fluorescence in order to measure the sponge's oil remediation and recovery capacity in different oil spill conditions. And so the FBG sponge aimed to do two things: recover and remediate both that excess heavy oil, but as well as that soluble oil. So one of the first experiments I conducted was placing one of the FBG sponges in a simulated heavy excess oil solution. After 10 minutes, the sponge was squeezed into 200 milliliters of deionized water and then diluted to 22 liters of water so that the oil was now soluble and was able to use fluorescence to measure the recovery and remediation. And from that data, I was able to determine that the sponge absorbed 37.4 grams per centimeter squared, and around 100% of that soaked up oil was recovered. Using the saturated water from step 1, a new FBG sponge was placed in the now soluble oil water solution, and samples were taken over a few days, and the samples were first placed on a shaker to simulate wave movement. And over a course of time, compared to a control, which was a solution with no sponge, and to a solution with a plain polyurethane sponge, the FBG sponge showed a significant decrease in the benzene concentration over a course of 6 days. I also discovered that within 4 days that the FBG sponge had an oil removal capacity of 25.7 micrograms per centimeter squared, recovered around 57% of the soluble oil. Next, in order to validate the successful absorption of oil, another way to look at that absorption was using an ATR-FTR, which conferred the decontamination of water from oil and other contaminants from the sponge, especially after the step 2 procedure of the soluble oil treatment. And SEM analysis of the sponge indicated that the effectiveness and the prolonged integrity of the sponge remained, and the presence of the oil in both the excess trial and the soluble oil trial within the pores of the sponge was infirm true based on the SEMs. And in the future, I would like to investigate additional sponge materials as well as other natural absorbents, as well as apply the FBG sponge into field studies and look into scalability. Thank you so much and have a great evening.